Hello, in this tutorial I am going to explain the basics about Geogebra. First of all, we have to know what is Geogebra. Geogebra is a software that allows us to compute the mathematics in a dynamical way. That's it. For example, if we create a line, we can make it dynamic, we can move it. If we make a point, we can make it dynamic as well. We can create animations, etc. It will be very useful for solving some exercises in class and demonstrations as well. Now let's speak about the program. When you open Geogebra, this is what you find. You will find up here the menu with different options, the tools that you are going to use for constructing your figure, the algebra window, the graphics window, the input bar that you are going to use to introduce equations, declare variables, etc. And here you have an arrow that if you make a left click with the mouse, you will open these options. We are going to work with algebra, but you have to know as well that it is possible to work with a spreadsheet, that is a kind of Excel, with computational algorithm systems which solve equations, and 3D graphics, for example, where you can make 3D figures, and probability, that is related with statistics. Now we are going to see the menu bar. And in the menu bar, the most important things are to save the files, the worksheet. So for doing this, you go to File and Save. Here you choose the path where you want to save it and give a name, and you then press Save. It is also very important to know that there's a command called undo, that it's here in the right of your screen or here in Edit. It is also very useful the command Control Z, which I think you will go faster. In View, you will see as well the perspectives that were here. Remember that this is we are not going to use this. And the construction protocol. So when you make your construction, here you will see the steps you followed, and it can be very useful for knowing where you were wrong or these kind of things. In options, you find as well the rounding, so you can choose how many decimals you want to have in your numbers. Imagine you have a segment with 4.567891 and you only want to show 2 decimals, so you press here and the program will show only 2 decimals. And the font size, that you can choose how big you want to have your fonts. For example, now you see it's bigger. I will let it at 12, that is the best option. In tools, you can customize your toolbar, but all the tools you are going to need are here, so you don't have to worry about this option. And finally, in Help, you will find the manual. This is very useful because it will show you different things that are not explained in the tutorial. So if you want to go deeper, you can come here and look for what you are looking for. Now let's go into the important part of Geogebra, the construction of the figure. So there are many ways to do these constructions. You have to know that you can work with the input bar, or you can work with the toolbar. So for example, if you want to define a point, you can go to the input bar and call this point A. It's equal to, for example, let's see the point 4,5. It is very important to know how to define the point. So a point it's equal to, and you open brackets for the x coordinate, comma, space, and the y coordinate, and then you close the brackets. If you do it in a wrong way, the Geogebra will detect that it is wrong. Let's see an example. B equal, for example, imagine that I forget the brackets. I put 4, 5, and then the Geogebra says it's an invalid input. For that reason, it's very important to know the commands. In help, in the manual, you will find how to define the commands. Okay, we can define a point as well, clicking on the graphics view window, and then we can write the values we want. We make a double click with the left button of the mouse, and here we can choose the point. Imagine we want the point to 1, for example. So here it is. Let's see a little bit more about this algebra window. In this algebra window, you have the possibility to make the object invisible, which will be very useful. For example, imagine you are doing a construction and you need auxiliary lines. So here you can make the objects invisible. Just press this circle, which is in blue, and the object will disappear. As you see now, it's in white. When it's white, the object, it's invisible. It hides it. Now we press again and it's visible. Let's see more things about this algebra window. So if you go into the geometric reference you have here, and it can be a point, it can be a line, whatever of these tools, and if you go to the definition and press the right button of your mouse and go to object properties, here you will have some different windows. Let's see some basic things about here. So for example, if you want to change the name of the point and you want to call it C, for example, you can do it here. Now the point C will be called 45. You press enter and then it's changed, as you see. In caption, you can write whatever you want, hello for example, and then when you are showing the label, you can put here caption, and it will show what you wrote here. If you change for buy and you press enter, it will show you buy. You can put as well in the label the name of the point and the value. So the point C is 545. It is possible to hide the object from here as well and to show it. As you see, remember the white circle means that it's invisible and the blue one means that it's visible. You can show the trace as well. This is very nice in the animations, as you will see later. But for example, if you press show trace, this option, if you mark it and you move the point, it will show you the trace that this point is following. In the color, you can change the color of the point as well. As you see, now it's green. The style, how big you want to make your point. This is bigger, and the style. Maybe you want an arrow or whatever. Across. I will mark this option, and if you move the screen, the traces disappear. In algebra, this window we are not going to use it, and in the advanced options, the only important thing to know about here is this condition to show object, that it will be very useful in the future, but just know that it is here. Here in the toolbar we will find more options. If we press in the vertex this red arrow, we will see more tools that we will need for our constructions. All of them are here, you won't need more. So now we are going to see this one, attach or detach a point, because this one, pointing on object, it is not going to be used. So let's go through this one. If we want to attach a point through a figure, through a line, through an axis, whatever you want, we just have to select the point we want to attach and the line, axis or whatever you want to attach it. So for example, I will attach this point B. I make a click with the left button of the mouse, this point B, to this x-axis. I do it again, but in the axis. So now this point B is attached to this line, and it will move through this line, as you see. For detach a point, we just select again the point, and it's detached. We want to attach it again, so we select the point and now the y-axis. Notice that the color of the point changes when it's attached. This is because it has a dependency, so the color is brighter than the other ones, than the points that are not attached. For example, this one, the point A is not attached to anything, so it is darker than this one. The next command we are going to use is intersect. We have to select two objects and then it will show the intersection between these two objects. For example, now we take the object and the y-axis and the x-axis, we click on them, and here you will find the intersection between these two lines, these two axes. When the point is in black, that means that it cannot move. This is because it has so many dependencies, and then it is impossible to move it. The following command is midpoint or center. So we have to select 2 points, point A and point B, and Geogebra will create a new point that is the center between these 2 points. It's in the middle. So if we make the point A bigger, the point E will be always in the middle. But remember that point E, as is in black, we cannot move it. So this is why we cannot move the point. If we go with B through the y-axis, you will see that the point E moves, but we remember that we can't move this point. Now let's go to the next tool, that is the line. But first of all, I will erase the Geogebra file and I will create a new one. So let's move to the line. For defining a line, we have different options. We can write the function. For example, if we want a line that goes through the point 0, 0 with a slope equal to 1, we can write it here. So y is equal to x. And as you see, here you will find the line. We can create a line as well, defining 2 points. For example, if we have the point 0, 0, we create it here, A equal to 0, 0, we create this point in the input bar, and then we create another point equal to 2, 1, for example. As we have 2 points, we can define a line. So we select 1 point and the other point, and then we have the line. Remember, you have to click on the command and then use the 2 points. Let's delete this line now. Okay, the next tool is segment. And for defining a segment, we need as well 2 points. So we will use point A and point B. The segment will be defined by point A and point B. So here we have the segment. Note that here in the algebra window, the Geogebra program, this program detects that this is a segment, that AB is a segment. And the value of the segment, the length, is 2.24. This is the length of the segment. The following tool we are going to use is a segment with a given length. So for example, if we want to create a segment from point B with a length 7, we input here the length and it will create that segment B with the value of 7. It's important to remark that Geogebra only does segments with a given length parallels through to the x-axis. The next command I am going to explain is the ray. The ray creates an infinite line with 2 points. So first we select point A and then point B, and as you see, it will create an infinite line. The next tool that is not very useful, but it's here, it's the polyline. The polyline creates different lines and gives us the length of these lines. I will use this polyline to explain how to define the properties of our object. So if you make double click, you will see here the definition of this object. This object is a polyline with all of these vertex. For example, if we want to add another vertex to this polyline, we just add the point A, for example, and the polyline will have another point, which is A, as you see here. So for that reason, it's very important to know the commands and the definition of the objects. You can find them in the manual. It's here in the help window. Finally, you have vector and vector from point. That these two tools are not necessary for our constructions. The next step is the perpendicular line. For using this tool, we need one point and a line. So for example, we will create this point, and now we can use the perpendicular line. We want a perpendicular line to this axis x that it goes through the point A. Here we have our perpendicular line, it's here, x equal to 6.5. Now, if we want to do a parallel line, we have to follow the same process as before. We select an axis, for example x-axis, we want a parallel line through this x-axis that goes through the point A. So here we have our parallel line. The next tool is the perpendicular bisector. So for using this tool, we need another point. We need 2 points. For example, this one. And now we can create the perpendicular bisector. It will create a line perpendicular to these points, these 2 points. It is very important to know that this perpendicular bisector, this tool, is faster than if we create 2 points. We make the segment between these 2 points. We find the midpoint from these 2 points, and then we create a perpendicular line from this segment to this point, and then make this line, which is D, this segment D, we make it invisible. So as you see on the point F. So as you see, it's the same result, but if we use perpendicular bisector, it's faster than doing all the construction. The following tool I am going to explain is the angle bisector. This will create a line between the half of the angle of 2 lines. So for example, if we select the line A and line B, it will create a line which is the half of the angle of A and B. So for example, A and B, we know they are perpendicular, so they have an angle of 90 degrees, a right angle, so the half, which is the bisector, is 45. For explaining the following tool with this tangent, I am going to erase all what I did before. So I will create a new worksheet. The next tool I'm going to explain is tangent. So for explaining this tool, I need a circle and a point. So I want a tangent line from this circle that cuts through this point B. So I go to the tangent, I select the circle C and the point B, and it will create a tangent line that cuts in B. Let's delete these operations. for explaining the following one, which is the best fit line, because polar or diameter line and locus are not used, so I won't explain them. I will explain best fit line, that it makes like a linear regression between different points. So I will define some points from here, and the idea is that this tool makes the best line from all of these points. So I will select two of them, and then I go to the properties of this line, and as you see, it says fit line from point A to B, but I want to add to the list more points. For example, J, I, H, G, and C, for example, and it will make a line with the best fit line from these points, for these points. That is this one. If I add more points, for example, I will add D, E, and F, it will create another best fit line. So as you see, this one is not very useful for our constructions, but in the near future you can use it. Let's move to the polygon tool. For defining a polygon, we only need different points. For example, if I want to create a triangle, we will have to make 3 points. And here you have your polygon. Note that the color is different, so that the program, when you use polygon, detects that it's a polygon, so it's not a sequence of lines. So for example, if we create here a triangle, these are different segments, but the program doesn't detect that it's a polygon. So here you have the area of the polygon, and here the different segments that are in the polygon. Next tool I am going to use is the regular polygon. For defining a regular polygon, first we define a size of the polygon, for example this one, and then we choose how many vertex do you want to have. For example, if you want to create a triangle, we will choose 3 vertex. If we want to create a square, we will choose 4 vertex. This is all from the regular polygons. Then the rigid polygon and the vector polygon are not useful in our construction, so I won't explain them. And then I will erase all of this for explaining the following tools. Now we will see the different possibilities we can have with the conic objects. The first one is the circle with centers through point. So for defining this object, we just need one point, which will be the center of our circle, and another point that will be the radius of this circle. So here we have the point B, and here we have the point A. In the algebra view, we can see as well the function of this conic object. The circle with center and radius is very similar, but the only difference is that we have to define only the center of the circle, and the radius is defined by a value we want to choose. For example, a radius of 2. Now here we have our conic figure with a radius of 2. With the compass, we can create a circle, first of all knowing the radius of this circle. For example, if we want a circle with the radius of BC, we just select the point B and then the point C, and we will have our new circle with the radius BC. We can move this circle wherever we want. So for example, I want to put it here in A, I will let it here. For the next tool, that is circle through 3 points, we will just need 3 points. For example, we will define point D, point E, and point F, and now we can create a circle between these 3 points. Here we have our circle defined by these 3 points. I will erase now these objects for explaining the following one, the semicircle through 2 points. So as the definition say, we will need 2 points for defining our semicircle. So let's select point A and point B, and here we have our object defined. The next tool is very similar, the circular arc. We just need to select the center of this arc and then the radius of that arc. The length, we can choose the length we want. For example, this one, and here we have our arc. We can move C just selecting the right button of our mouse and moving C around the screen. Finally, the circumcircular arc, we will create like an arc, but first of all we will select one point that will be the beginning of our arc, another point that will be a point where our arc cuts, and finally the final point. So here we have our circumcircular arc. All of the perimeter of the objects is defined here. So this is the length of C, this length, and the same with the other ones. Finally, we have these two tools, circular sector and circumcircular sector, that are very similar to these ones, because here we define sectors. So let's make an example, because they are not very useful. So the conic figure in E, Geogebra detects that it's a sector, so it gives us the area of this sector, but it is not very useful for anything else. Now, once explaining the conic objects, I will explain the angles. These objects from here, the ellipse, hyperbola and parabola, and the conic through 5 points, are not very useful for the constructions we are going to do. But if in the near future you need them, you can go to help, and in the manual you will find the explanation of these objects. So now let's move to the angle. Here in this bar we have different tools. Now I will explain the angle and the angle with given size. So for defining an angle, we need 3 points. This, the vertex, and these 2 points. First of all, we will define the first point, the vertex, and now the other point. And here, as you see, we have our angle. The value of the angle is 136.4 degrees, and we can change the properties of this angle. So for example, if we want to change the opacity, so our angle is darker, just this is, and for making it more understandable and nice. Or the style, here, the lines. This is because I am explaining this because maybe if you have more than an angle here, for example, if you have another point here, and you have to make another angle between B and D, so let's do it, B with vertex A and D. As you see, these two angles are in the same way, so you cannot see them very well. So changing these properties and making it, for example, the color blue with a bigger size. So now maybe you can see better these two angles, the angle beta and angle alpha. Geogebra detects that these angles are in degrees, but it is better to work in degrees rather than in radians. Finally, I will explain this one, the angle with given size. So we need the same as we did with the other tool. But finally, the third point will be defined by the size of our angle. For example, we define point P and then the vertex. And now we can choose the size of our angle. For example, I will say 180 degrees. So now, as you see, here we have our angle, that is gamma. I will make it a little bit bigger so that you can see the three angles we have defined. Here it's gamma, which is purple, alpha, which is green, and the other one beta, which is blue, a bright blue. Now, if we want to compute the distance between C and D, between these 2 points, we just have to go to this tool, distance or length, select the 2 points, and Geogebra will create a text and with the distance between these 2 points. The other tool is the area. So for computing the area, we need to have a closed object. So for example, a circle with this length, with this radius, for example, and select the tool area. We select the object, and finally here we have the area of this circle, area of the object E, which is this conic object. It's equal to 13.89. Finally, the slope of a line. So for computing the slope of a line, first we need a line. First of all, I will erase all of these objects so that it is more clear. So if we have, for example, this line, I choose it random, and now we select the tool slope and then the line. Here we will find the slope of this line, which is 0.89. I mean, M means the slope of this line. And finally, create a list, and we will not use this tool because it's not useful for our constructions with the geometry files we are going to use. Now we will move to these tools called reflect. So for example, and if we want to create a new object about a line or a point, we can do it with Geogebra. First of all, we have to choose the object that, for example, I will create a triangle, and if I want to reflect this triangle about a line, for example, this polygon I created about this line, we can do it with Geogebra. Just we select the object and the line, and then we will have the same object in the other side of the line. Note that the distance between the line and the object is always the same for both sides. For example, if we want to reflect about a point, so we create a point F and a point G, and we want to have another point here, F', we can do it with this tool. So we choose the 2 points we want to, the point and the point about the reflect. So now we will have the new point. It's very important to know the property of Geogebra, that the distance between these 2 points is the same always done between these 2 points. So for example, if I move a point G, the distance will never change between FG and GF'. It's always the same. This tool called reflect about a circle is not very important in our construction, so I won't explain them. Rotate around a point does the same than creating a new angle with a given size. It's very similar to this tool. So for example, if I want to rotate the point F, I select F with the left button of the mouse. The vertex G, I want to rotate it, so for example 90 degrees. I will have my new point F at the distance of 90 degrees. I will see that it's 90 degrees just to make this demonstration. So as you see, it's 90 degrees. Note that it always will be 90 degrees, so if I move, this point F1 never changes from 90 degrees. And finally, these two tools are not useful in the construction, so I am not going to explain them. Remember that if you need it in the near future, you can go to help in the manual and you will find the definition of these two tools, and you can check here. Now that we have seen all the tools for our constructions, we will see how to introduce a text in the graphics screen. So we go here to ABC this tool that is text, and we press with the left button of our mouse to the screen. We can write a text, for example, this is a test. Here we have the text we want to show. If we press OK, here we will see the text. With the right button of the mouse, you can move the text around the screen, and with a double click, we go again to the text, to the edition of this text. There are different important things. For example, here you have different symbols you can use. The angles are very useful, etc. For example, delta. And it is very useful as well, objects. In objects, all the points or angles or area of the polynomials you have, you will show the results here, and they will change dynamically. So for example, if you have the angle alpha here, I am going only to show the angle alpha, it will show you 90 degrees, because now this angle is 90 degrees. But for example, if I make a dynamic angle, so for example I create an angle between C, D and E, which is between 0 and 180 degrees. So here in the properties of the object of this angle, I went to this property that you can change the value of the angle. So I say that I want the angle between 0 and 180 degrees, and here I have my angle beta. Here it's better seen. So your angle, my angle beta, that is, you can see as well in the algebra windows, that it's 74.83. If I move, the size of this triangle will change dynamically. So I can make a text, for example here, that shows me this angle in a dynamic way. I just have to go to objects and then select the angle I want. So for example, I want to say the angle between D, C and E. And now I select the angle beta. So here I have my text. And now if I move the construction of the triangle, as you see, the angle beta changes here in the text as well. If you want to do it with symbols, it's impossible. You only can do it with objects. Here beta. So if you for example try to do it with beta here, this angle won't move, because it's not the definition of the algebra construction. So as you see here, beta is just a text, and here it's a value. It is also very important to know that the text allows you to use LaTeX. So if you don't know how to use LaTeX, I will send you some links in the PDF where you can find good tutorials of how to use LaTeX, because it's really useful for showing formulas and this kind of demonstrations. So for example, if you want to make a fraction, just to show you how it works, you have to write it in this way, frac, and then here you put a number or an object or what you want, and then it will show you the result. So for example, this is, I chose it randomly. So here you have the LaTeX text. As I said before, it's very important that you know how to use it. For example, if you want to write this is a test, as you see, the program LaTeX does not detect you that this is a space. So for that reason, you have to learn how to use it in a properly way. Finally, here we have more options that I won't explain them because they are useful for our constructions. Just to this tool here, image, is for inserting an image. It's the same one as I explained it before here in edit, that is insert an image. It's the same one. And pen, that you can write whatever you want here. I will erase this. Or a freehand shape, that here if you want to make a function, it's a function, as you see here, freehand of x, it's a function, but this is not useful, and this is all for this tool. And now we are going to move into the last square and arrows, which are very important: the sliders, checkbox, buttons, and input box. But first of all, I will erase all of this construction. Just say new, and that I don't want to save this. Now let's move to the last part of the tutorial, which in my opinion is the most interesting one, because you can interact with the constructions you made. So for example, if we want to create a slider that takes the value of x, for example, and we say that the minimum value is 0 and the maximum is 5, this is the interval here, the slider will create this kind of line where you can put the values here along this line. For example, from 0 to 5, as we set in the properties of the object, the interval is from 0 to 5. I will say an increment of 1. Here I can modify the options as you know. So now A will take different values from 0 to 5. Why is it important, this, and very useful? Because now if I want to create a point, for example, and say that I want that this point move along the x-axis depending on the value of A, I can do it. So for example, let's create a point A. Remember the syntax of the input bar. So the point must be equal to, we open brackets, here we introduce a value of the x coordinate that will be A, and here we introduce the value of the y coordinate that it will be 0. So what does this mean? So for example, when A is equal to 1, here we will have the coordinate 1, 0. When A is equal to 3, for example, here we will have the coordinate 3, 0. Let's see that. So now the point is 4, 0. Why? Because the slider takes a value of 4, A equal to 4. Now if we change the value to 0, it will go to the point 0, 0. And as you see, you can make this dynamic. Depending on the value of A, it will change. We can make an animation as well. If we press the right button of the mouse and we say animation on, this slider will move. I am not doing anything, it's just moving automatically, it's animating. For stopping the animation, I have to go again to the slider, right button, and click again on animation. So now it's stopped. We can give more uses to the slider. So if you remember before, we used the circle with center and a radius. And if we define the point first and then the radius, instead of inserting a value of 3 or 4, we insert the value of the slider A. Now the radius of this conic object C will take the value of the slider. So for example, now this circle takes the value of 1. And if we move the slider to 3, the radius of this circle C will be 3. As you see, it changes the point and the conic value. It is useful as well, for example, if we have a regular polygon, if you remember, we could choose the number of vertices. So for example, if we want to give A vertices, now with a value of A, we cannot construct any polygon. But for example, it's undefined, as you see here in the algebra. In the algebra windows, the polygon is undefined. But now if we give 3 vertices, now our polygon will be a triangle. With 4 vertices will be a square. With 5, another object. So for that reason, it's important to know how to work with a slider. Give a value, a variable called A, and then with this variable we can play with different things. As you see, it moves around an axis, or it can move around a line, for example. It can change the radius of the circle and more things. Now let's move to another interesting tool as well, that it's a checkbox. So the checkbox, what it does is to create a box that when you click on that box, it creates a boolean that it says that it's true or false. For example, here you can introduce the name that you want to give to your checkbox. For example, I will give an example of checkbox, this name for example. And now, as you see, this checkbox has created a boolean value h that when the checkbox is on and it has this tick, it says that the boolean value is true, and when you click again, the boolean value is false. So for example, if we want to make this slider appear or disappear, we can create a checkbox. I can say, for example, I can give the name of this checkbox slider, and now we can select the slider from here, from the list, or from the screen. So I select this checkbox, with the checkbox the slider, and here, as you see, it will create a checkbox that when I click on this checkbox called slider, the boolean value is false, so the object disappears, and when I click again, the boolean value is true, and then the object appears and you can work normal with it. So this is the main utility of the checkbox. Now the following command, which is the button, It's maybe one of the hardest ones because you have to work with Geogebra script. So for that reason, in the PDF, I will write some links so that you can change how it works, and maybe you can go deeper there. But I will not explain the scripts in the tutorial. So let's move to the last tool here, that is the input box. For when you create an input box, what you do is to give it's like a slider, but instead of giving instead of moving around a line, you just insert with your keys in the laptop. You insert here the number. So for example, first of all, I will have to define a variable that I will call it a variable, which it will be equal, for example, to 4. Now, as you see here, it created a number which is equal to 4. Now, if we go to the input box and we create an input box here, that I say, for example, radius of circle M, and the linked object is this variable, and this variable I defined it before, and I say apply. Now, when I change here the value of this variable called variable, which is equal to 5, now as you see here, it will change. It's the same idea of the slider, just the main difference is that first you have to define a variable, and then here you can change it with the keys of your laptop. But for example, if now I want to create a circle with center and radius, as I did before with this object C, I create it, for example, here, and I say that the radius is variable. Now the radius, it will be 5. If I want to say that the radius of the circle is 2, I insert 2 here and it will change. And as I said before, you can change the properties of the object. So instead of saying radius of circle M, as it is GeoGebra defines automatically this circle, and with the letter K, I will say, for example, here K. So now radius of circle K is equal to 2, and you can see here that the radius is 2. If I say 1, now the value of variable is equal to 1, and we link it the radius to this object, and so that the radius is equal to variable. Now it takes the value of 1. And that's all from the GeoGebra tools.